let's go to the distributive property that I mentioned earlier. This sort of combines the multiplication and addition, and it's very important where you have something, you have a so you have this part right here. You have a bunch of terms, let's say, being added, but then and you want to multiply it to some constant. Generally, the constant, it could also be another algebraic expression. Well, how do you do that? You could go ahead and add the terms inside if possible. But another thing you could do is you can multiply that term to everything inside one by one. And this is known as distributive property. So this A is going to get multiplied to B and to the C. And then we can apply the addition. So let's look at this example right here. The 7 is being distributed to be multiplied to the 4, and then it's also being multiplied to the square root of 3. So 7 times 4 is 28. Now, when you can't multiply 7 to square root of 3 if you want to keep an exact value, so we just keep it 7 square root of 3. Let's look at the algebraic example. So 5 times 3x, we can put those together, and then the 5 also distributes to 7. So then that simplifies to 15x plus 35. Okay, so negatives always cause some sort of issue, and so it's very important to keep track of negatives at all times, especially if you're multiplying or dividing by negative numbers. So here, if I want to distribute this -2, I have to distribute it here, here, and here. But each time you multiply by a negative number, you change the sign of the term that is getting multiplied. So -2 gets multiplied to the b squared. B squared is positive, so now it ends up becoming -2b squared. -2 gets multiplied to 3b. 3b is positive, so it becomes -6b. And then finally, -2 gets multiplied to -1. Since -1 is positive, negative, and negative, now we end up with positive 2. So the general rule, if you multiply or divide by a negative number, then the signs change.